Thank you for joining us. Today we are going to talk about open source based architecture for observability. And I'm Tiani. I'm a solutions architect for AWS. And Lucas?
And I am Lucas, also solutions architect from AWS. And only to get things started, making a case for open source observability. I think everybody in the room is already convinced about using open source software. And only to emphasize, the benefits are the ability to customize our workloads, to work on making it efficient, and having transparency of what's happening with data, what you're sending to your destinations, and the impact of this data, and of course, benefiting from the community around these technologies. But we're not just talking about open source observability, we're talking about managed services for open source observability. And what is the use case for a managed version of an open source technology? Put it very simply is using AWS, like making AWS responsible for more parts of my workload. So if I'm running my software in AWS, of course, AWS will be in charge of the infrastructure. And maybe for me that's enough, but I may be more interested in being, for example, an OpenSearch administrator and not a systems administrator. So using managed services will allow me to focus more in configuring my open source stack and less in the underlying operational system, for example. And having AWS taking care of how exactly it will scale my environment and stuff like that. So only to get everybody in the same page for the concepts that we will talk about in the following slides. When we talk about observability, we are thinking about the ability of saying what's happening to a system from outside of the system. So we rely on telemetry. And that must have an objective, like a business objective. Observability is not a thing in itself. It needs to serve a purpose, a business purpose, an operational purpose. And to achieve these business targets, we will use telemetry signals, and we will adopt the 3 classic signals. I know there are different ways of thinking of telemetry signals, like one single signal for everything or 6 different signals for everything. But here we're going with the classics: metrics, traces, and logs. And metrics, I don't know if it's something that you have faced, but usually use time series databases to store metrics data. And the challenge with this sort of database is cardinality. So we will not use metrics for everything, but mostly for things that we already know that we need to track. But for more unpredictable data, we usually will go with logs. But when it comes to managing distributed systems, we resort to traces to understand quickly how each microservice, for example, is including latency in my entire storage to answer a user request. Going into detail about traces, since between the 3 signals is the least used, traces are only a collection of spans. A span being one call that I will register that has a latency attached to it, that has a status like a error or not, and several other information that I can add to that particular span, like attributes such as AZ and stuff like that. And I can visualize these spans that will make a trace in 2 ways usually. As what I call waterfall visualization, where I can see each call, the time it took to be completed, and service maps where I can see the connections between the different microservices, the different parts of my system that I'm tracking with traces. And we have prepared a demonstration for you. And in this demonstration, we will use OpenTelemetry to bring data to our data stores. And we will use OpenTelemetry to instrument our applications, our microservices, but also we will collect data from a Kubernetes cluster using Prometheus. We will not only collect traces and metrics, we will also collect logs. So we also have a file log receiver to bring some logs from Kubernetes to our destinations. We will have a span matrix processor, so we will generate metrics from traces. And finally, we will export this data to OpenSearch and Amazon Managed Prometheus. And looking into AWS Managed Services for open source observability, at the core, we have two different technologies for data collection. Amazon distro for OpenTelemetry and Amazon distro for FluentBit. So these are open source projects, but they are governed by AWS. That means that AWS security will approve the launches of the services, for example. And if you, for example, have support from AWS, you may be able to ask for help with these technologies. And in the aggregation layer is where we're going to store our telemetry data. So we're going to use Amazon Managed Service for Prometheus for our metrics, and Amazon OpenSearch service for everything else. And finally, in the visualization layer, we have two alternatives here. One is Amazon Managed Grafana, and the other is the Amazon OpenSearch service itself. It has this new experience, the OpenSearch UI, but right now, since we are correlating data from two different data sources, we will resort to Grafana instead of Amazon OpenSearch service. Otherwise, we would go with Amazon OpenSearch service. So this is a very simple visualization of what our architecture looks like. We will have AWS distro for OpenTelemetry sending metrics to Amazon Managed Service for Prometheus, and sending logs and traces to Amazon OpenSearch. And finally, we use Grafana to correlate this data. But a more complete visualization would include the source, which is an application running in Amazon EKS, and OpenSearch ingestion between AWS OpenTelemetry and Amazon OpenSearch. And the reason we have OpenSearch ingestion over there is that we're going to use that to convert our signals that comes into OTLP format, that is the OpenTelemetry protocol, into Amazon OpenSearch document format.
So, talking about the ways you can use OpenSearch inside AWS, of course, you can use the OpenSearch self-managed, and you have the control of the whole infrastructure and your domain, your cluster. So you deploy your EC2s, and you deploy the OpenSearch inside your servers. The second one is the provision. We are talking about OpenSearch services. And you have the control to deploy, to size and configure your cluster. But once it is deployed, you don't need to manage servers and infrastructure anymore. You have the control of your OpenSearch environment, but you don't need to deal with infrastructure. And of course, the OpenSearch serverless, the name already said to us what it is. So you don't need to deal with infrastructure, and you don't have to deploy your OpenSearch. You are on the owner and consumer of your environment. So wrapping up, the first one, you are the system admin, and you are the admin for your OpenSearch environment. The second one, you are only the manager of your OpenSearch, and you consume this environment. And the third one, you are only the consumer. So talking about the architecture of the provisioning one, most of you may know that how a cluster of OpenSearch is. But when you're using an OpenSearch service, You deploy, we call a domain. So you have the domain, and the domain is controlled by a bunch of instances, and the integration, the iteration that you have with your environment is via a load balancer that provides you the API to manage, to indexing, to query your data inside your cluster. The data nodes are the workers. They hold the data. They get the requests for indexing, and they receive the queries for searching. You may have ultra-warm nodes that you can put your older data, and as it uses S3, you have a good cost optimization here using this kind of tier. You may choose or not. And of course, the leader nodes that are the orchestrator of the clusters. As we are using OpenSearch ingestion that is powered by Data Prepper. Data Prepper, if you were at the previous sessions, Kevin told us about Data Prepper is better than I, of course. But this is the layer that you can prepare your data to put inside the OpenSearch. And the advantage here to using OpenSearch ingestion is that you don't need to deal with infrastructure, and there is some blueprints already ready for you to use and start collecting your data. So let's start with our first demo.
And this is a live demo, so ask everybody to be a little patient. All right, so there is this string here. OK, so this is the application we are observing. It's the OpenTelemetry demo. It's part of the OpenTelemetry project, and is a good choice if you want to test your stack, see what's happening with signals, the experience with correlation, finding things happening in your environment. Is a mock e-commerce, so I can like purchase 2 telescopes, for example, place an order, and it also has this nice recommendation thing. And yeah, that's the OpenTelemetry demo, and it's a good suggestion if you want to like test your environments. And this is a Grafana dashboard where we are seeing the health of all microservices that are part of the OpenTelemetry demo. And the way data is arriving here is through OpenTelemetry that is generating metrics from our traces and sending this metrics to Prometheus. And this OpenTelemetry will also send these traces to OpenSearch. So we have like the same source, and in OpenTelemetry, we are routing that to 2 different places. And these are the basic observability signs, one can say, the requests, errors, and duration, or red signals. And I will select one of these microservices here, and now I'm using the data link feature from Grafana that will open a second dashboard, bringing some variables from the first dashboard. Which variables? The time range. So if I had a different time range, it would bring the same time range to the second dashboard, and this service name variable over here. And in the second dashboard, I will have the information of the traces that are being collected, and also, if I want, the information about a specific trace. So I have a summary row, and here I have a trace row where I have the service map and the logs for that particular trace. And in this first row, I can select the name, the ID of another trace, for example, and it will update the value for the trace ID variable over here and the information in this trace row as well. The way these variables are configured is, I think it's the variable configuration. I can't really see. No, it's not. Sorry, folks. Here. Let me see. Is it? No, it's links. So, sorry, guys, just because variables is the next one. Let's see it here. Here, variables. Okay, so I have 3 variables, 2 that I'm using in the dashboard, and the first one is the service name. And the service name is a query variable, so it should bring information from a data source. And the data source I'm using here is Prometheus. It should bring me all the values for the dimension from the label Kubernetes deployment name, and that happen to have the Kubernetes namespace name equals to hotel demo. That is the Kubernetes namespace where I deploy the OpenTelemetry demo. And here I have a preview of the results of the query, where I have the name of all services that are part of my application. And I have a second variable that is trace ID, and this is another query variable. But the cool thing is it's an OpenSearch variable and not a Prometheus variable. And in the query configuration here, I'm using Prometheus variable to filter the results of my OpenSearch query. So this is one way of making the correlation works at Grafana level, using one variable to filter the other. So I'm only seeing trace IDs where at that span, for example, I have the service name equal to the service name I selected in the first variable. So the way I use these variables in the dashboard is, for example, in this logs visualization here, I will have a query, I will send query, where I'm filtering by the service name, the Prometheus variable service name. So again, I'm using the Prometheus variable to filter the values of an OpenSearch query. So this is how correlation work at dashboard level, okay? And you can also have like a different kind of dashboard. For example, here we are solving the problem of someone that is in charge of the product and needs to see traces in detail. But maybe you're working with infrastructure, so you need all the logs for your pod, for example, over time, not filtering by traces or anything, and some metrics about your pod. So a different dashboard like this one will make sense for you. And this is the stack demo. Now we are going to talk about other cool things that you can do with this stack. Just give me a sec to move this here.
All right. So as we are using, for the next demo, we are using generative AI and MCP, the obvious must be said. This is the AI stack for AWS. Of course, we are not covering all the stuff here. We are just just want to say that we have 3 layers inside this stack, that the infrastructure enables you to build up the things from scratch. I mean, if you want to build up your own foundation model, and you have the infrastructure layer that helps you to do it. And you have the agent development software layer that helps you to work with LLMs that are read for you in the AWS cloud, and you have the application. So we are going to pin up the Amazon queue. That is, it's an AI assistant that you can use for software development, that you can use for review code, manage your cloud resource. You can do a lot of stuff with this AI assistants. We are showing you the Amazon Q developer CLI that you can use in your machine, in your environment. And MCP. MCP is a protocol that was created by Anthropic that integrates AI assistants with custom tools and services. And you can easily integrate with AWS resources. And the architecture is pretty simple. You have the AI assistants that calls the MCP server, then interacts with the AWS servers and returns what you called. Let's assume that someone wants to know how some information about their environment inside the OpenSearch. So the user will use the Q CLI, for example, and the MCP will interact with Amazon OpenSearch service and returns the status of the shards and the specific index for this user. Okay? So let me show you the first demo. Thinking of a sysadmin that want to control want to understand how the OpenSearch environment is, how the health, how the nodes, how the shard and index are doing. If you guys manage an OpenSearch environment, you know that it's kind of hard, do a lot of effort for us to have all the information right to know if our cluster are okay or not. So using the QCLI, let's go. All right. Using the QCLI, I'm going to ask the queue to bring me information about my cluster using natural language. So what is my index? How is my shards and nodes and etc. So now they are using MCP server that is connecting to Amazon OpenSearch service and collect all the information about my environment. It's ready? Yes. So now you can see that they are giving me the information about my OpenSearch environment. So it's an OpenSearch 2.11. How the cluster is built up. It's they have 6 data nodes, 3 master nodes, and all the information that a sysadmin uses for managing the cluster. Yes. And if you have a lot of applications running in your environment, you may not know all the architecture and of the whole environment. So I asked Q to give me a ask diagram how the architecture is building. So the Q will show me the architecture of the application, the ingestion layer, and the OpenSearch cluster. thinking of SRE or sysadmin team working in your environment with a lot of applications that they don't know the whole architecture, how powerful this can be. In seconds, you can see all the information that you need to understand how the application is deployed. Further, you can ask a specific part of the environment. You can ask the information about the health. I'm asking about the health of OpenSearch ingestion pipelines. Is it good, not good? How they are deployed? And the information will, they will use MCP to get the information. So my pipelines are ready, are running. There is no problem with them. And this is the configuration of my pipeline. So as a sysadmin or SRE perspective, if you wanted to have this information, use a CLI or a console, it will require some effort of you. So you can easily get the information, use this kind of technology.
Okay, so for our next demo, we have some observability use cases for MCP. And here, some things that I want to emphasize is that we run these tests with minimal context, almost no context. So we let the model figure out what was happening and so on. Other thing is that you need to be cautious, of course. This is supposed to help you in investigations, but you need to have proper prompts in place and educated workforce to make sure nobody will assume anything it says is the final truth without like making a second advanced guess. But it can be pretty helpful because we can't have everything in dashboards. Okay, we can plan for everything that may happen when an incident arrives. So here, for example, I asked what are the 5 services with the worst latency in the last 1 hour in the OpenTelemetry namespace. And it should work its way to understand which Prometheus workspace it should use and what are the metrics available in the OpenTelemetry for the OpenTelemetry namespace and so on. But it does that pretty fast. It already is done. It already has the answer to my question. And in this case, it is precise. But it was only Prometheus, no fun at all. And I want to see a result with OpenSearch. So here I have a logs question. What are the 5 services sending more logs to OpenSearch in the last 1 hour? And here it should have a greater challenge because you should need to figure out what is the mapping for the logs, how it should filter the logs, and so on. But still, it should manage to get the job done. And only to give you more information while it's working, it's connected to 3 different MCPs. One is AWS MCP that will allow the agent to talk to AWS API. The other is Prometheus MCP server. And finally, OpenSearch MCP server. Okay, and it's figuring out which tools it should use to get the job done. And I guess it's here it understood which field it should use to filter and to run the query. And here we have the result, the 5 services pushing more logs to OpenSearch in less 1 hour. And finally, the most interesting thing, root cause analysis. Because in the OpenTelemetry demo, I have a feature flag software that allow me to trigger an artificial incident. And we did that like some days ago. And you can see in the dashboard in the right that I have a spike. If you look into the bottom, you have this error spike. This is the ad service because we triggered ads failure. And the way it works is it should check the feature flag service and will launch an exception when it receives a request. So the question we asked the agent was, what happened with the ads microservice? And this is the wrong name of the service because the real name is add. So it should need to figure out the correct name by itself. And OpenTelemetry demo namespace, yesterday between 4 p.m. 5 p.m. PDT time zone. So it will do the same thing it did the first time because I didn't save context. I only started from scratch with the initial prompt. And it should try to figure out which metric to use to understand exactly when the problem happened and when it finished. And once it has determined that's what happened here, it will go to OpenSearch and search for logs from that particular microservice in that time range to achieve more information of what happened. And OK, I would like to work something interesting will happen. If you pay attention. It already said in the metrics part that the spans where the error was happening had this flagged thing in this spans. And then in OpenSearch, it will figure out that the errors mention flagged. So by the end of the reasoning, it will run again a query in Prometheus to understand what happened if flagged had an error at the same time or something like that. And this is not in the prompt. In the prompt, I only say start with Prometheus, figure out how to reduce scope, and then go to OpenSearch and find the logs with this scope predefined. So it went one step ahead and returned to Prometheus to search more metrics to finish its root cause analysis. And again, it needed to figure out the mapping of my index. I didn't had that documented. And if it was production, that would be something that I should include in a prompt or in a RAG or anything to make sure it should improve the performance and reduce the errors that could happen. But since it was just a demo, I tried to make it as simple as possible. Like to simulate the situation where we are having an incident and everything is not perfect, but you need to figure out what's happening, OK? So we have the root cause analysis. It will give us what happened in detail. We'll talk about the flagged service, the logs with errors, an example of the message, and also a recommendation to improve your system and avoid such a problem in the future. So this is more to give you an idea of what's possible and think of what you could build with such technologies. And here we are using AWS OpenSearch and AWS Prometheus, but it's more about the use case, more about the ideas of what you can do. So and this was our idea today, to show you what you can do with managed services from AWS and the use cases for these services. How can you correlate data from Prometheus and OpenSearch, and actually any supported data source in Grafana, and how you can use MCP to manage your environment, but also troubleshoot your applications. So that's it. If you have questions, any question? All right.
No questions.
Okay.
We return to you.
Sorry?
How can you implement where is going to MCP to OpenSearch?
The question is, how can you correlate the MCP with OpenSearch?
OK, so you're concerned about the volume of connections between the MCP server and OpenSearch. Usually, when I'm talking to customers that are implementing large-scale architectures for MCP, instead of running local MCP servers, they will move their MCPs to a central place, and from where they will be able to manage that at scale. And you can have rate limit the entry of your gateway, for example, where users connect to your MCP server. And there's a public AWS solution called MAS. That's MCP serverless solution, something like that, but where you can implement the rate limit at the entry point, or when your MCP is like your MCP is communicating with the technology outside, because the MCP will use the LLM models to figure out what you want and to build the query, for example. But when they communicate with the destination, for example, OpenSearch, they will communicate directly from their origin. So you can have a component, like an API gateway, for example, between your MCP server that is in this governed place and your OpenSearch destination. In this example, we are using a simple OpenSearch proxy running in a EC2 instance. I could have a component between this proxy and my local server managing this rate limit as well. Okay, so these are some forms that you can do that.
Something like a work line, OpenSearch work line, can stay between
I'm not familiar with the OpenSearch Go client, but if you can handle the rate limit in this layer, yes, you could have that between your calls and OpenSearch, of course. Yeah. Any more questions? All right, so thank you all. I hope you had a great event.
Thank you.
And if you have any other questions, find us in the hallway and in the event.
Thank you.
Thank you.